consumers across 7 different countries. And then globally, 58% of the consumers claim that they believe sustainability is somewhat important or extremely important when they decide whether they are purchasing a product or not. And of course, the percentage vary across different industries, but in general, 58% is a quite high number. And also, uh, this kind of valuation is also represented in the increased willingness to pay. So in the same survey, they also asked the respondents whether they are willing to pay a higher price if the products are more sustainable. And then you can notice that in different industries, such as consumer goods or the automotive industry, construction industries, most of the people, up to 60% of the consumers say that yes, they are willing to pay a sustainability premium. And they also mentioned that they are willing to pay up to about 1/3 more of the price if the product is considered to be more sustainable. So as a result, most of the companies start to release all this environmental information. So in this bar chart, you can see the percentage of the S&P 500 companies doing environmental information disclosure from 2011 to 2023. So the percentage has increased from 20% up to 98.6%, if I remember correctly, in 2023. And given the importance of the net zero, the CO2 emission reduction, you can expect that such voluntary information disclosure might eventually become mandatory. For instance, in last year, 2 years ago, 2023, the California Air Resources Board is required by the government to release all the environmental information. So it becomes a mandatory disclosure. However, if you look at the relationship between the environmental information disclosure and the financial performance of the firms, the conclusions are not consistent. So in some studies, they found that yes, the EID would improve the firm's financial performance, and some studies showed the opposite result. And then in some studies, they even find that there is no relationship at all. So one of the possible explanation for these conflicting results is that maybe the environmental information disclosure does not influence directly the supply chain performance, such as sales and profits. However, it influences indirectly by building up the manufacturer's or the product's green reputation. However, when the firms try to build up their green reputation, they face an obstacle, which is the distrust comes from the consumers. So in the same survey that I mentioned earlier, about 57% of the respondents think that there is some sort of greenwashing activities at the brands they use. And then among these 50% of respondents, about 80% of the people will do some individual research about how is the environmental claims of the company, whether it's true or they make some benchmarking with some other information they can find and do a comparison. So they don't just buy whatever the company is claiming. Similarly, in Europe, we have the same situation. So in 2023, the European Commission has done an investigation, and then 50% of the green claims in the European market give very vague, misleading, or even unfounded information. And 40% of the claims have no supporting evidence at all, and half of the green labels offer weak or non-existent verification. As a result, they rolled out 2 years ago a proposal for a directive on green claims. And in this case, they will provide a uniform criteria to assess the fairness of all the environmental label. So you can't just claim that, oh, my product is sustainable or is green without any evidence. You have to benchmark your performance with the uniform criteria provided by the European Commission. And if it's approved, then you can claim that your product to be green. And however, if you look at the past year's standards, you can somehow expect that this kind of uniform criteria might evolve over time. Let's take an example of the emission cap of the nitrogen oxide for diesel cars. Back in 2000, if you look at the emission cap, it's about 0.5. And then it has evolved to 2014 to 0.08. If you look at the data most up to date, it will be a much smaller number. So you can imagine a car emitting about 0.2 might be considered very efficient, energy efficient car in 2000, but nowadays it might be considered as a pollutant car. And so one of the biggest contribution in our study is to incorporate this time evolving, or better to say, more specifically, an error tightening regulations over time. And specifically, we are focusing on a supply chain for 3 reasons. So first of all, supply chain is one of the biggest contributors to the climate change. So about 50% of emission comes from supply chain across different industries such as food, fast-moving consumer goods, etc. But on the other hand, supply chain is also the biggest victim of climate change. So the United Nations Global Compact Council did a survey, and then they interviewed about more than 1,000 CEOs across the world. And about half of them say that they are struggling with disruptions, specifically caused by extreme weather events. And also 25% of them believe that this is one of the top 3 risks for the future business. And also, if you consider from the consumer side, the companies are also increasingly being held accountable for the environmental performance of the entire supply chain. So here I have looked for some scandals. For instance, for the Gap and Levi Strauss, they are blamed by the contaminant drinking water of their upstream raw material suppliers. And Staples is also accused for the harvest of rainforest timber, and Coca-Cola is accused by the consumers about the water-intensive agriculture partner. So in a way, you can say that all these 4 companies are somehow innocent because they are not the direct pollutant. However, they are held accountable simply because the environmental performance of their supply chain. So one of the consequences of this is that when firms choose to disclose their environmental performance, instead of only releasing scope 1 or scope 2, which is a direct or indirect pollutant caused by the same company, they also release the scope 3 emissions. So I'm sure most of you are familiar with this term, but just in case, the scope 3 emissions just account for any other companies of the upstream or downstream supply chain. And so, for instance, now from 2024, one of the environmental law corporate sustainability reporting directive will ask all the retail and wholesale sector to disclose all 3 scope emissions. This has a very giant effect on the retailing sector, because if you look at the total emissions in the retail sector, you will see that about 98% of the emissions actually comes from the scope 3 emissions. And among these 98%, 80% comes from the upstream players, which means their supplier or the manufacturer, etc. And this foster some vertical collaborations alongside the supply chain. So if we take the retail sector again as an example, we can find some collaboration, for instance, between Unilever and Walmart, and then they are working on a sustainability deals aimed at cutting greenhouse gas emissions and also minimizing the waste in the supply chain. Similarly, in China, Nestle is in partnership with Alibaba. In case you're not familiar, Alibaba is a very giant e-commerce platform in China. So they are promoting a decarbonization-friendly actions program to enhance the carbon reduction effort. So with all the elements I have mentioned above, the research questions of our study is to consider when we have an ever-tightening emission regulations or industry standards, what is the manufacturer's equilibrium investment in costly pollution reduction with or without the retailer's contribution? And also, what are the equilibrium wholesale price and the retail prices? Under what circumstances is profitable to outperform the industry emission standard? And also, we want to assess whether a cost-sharing program is efficient in both profit and also in reduction of the total emissions over years. So I will continue presenting some papers that are very closely related to our research questions. So basically, we will focus on the papers that study dynamic emission reductions efforts in a supply chain. So there is a stream of papers that consider in general the emission reduction, but in a very abstract term. So as you can see from this state variable. So they use the emission reduction as a state variable, and it can be improved by IT, which is the investment in abatement capacity, and it suffers a natural decay. And then this emission reduction will subsequently affects the goodwill dynamics and then also the instantaneous demand. However, the pollution per se is not explicitly accounted for. And in another stream, they do explicitly characterize the pollution accumulation. For instance, in this paper, we have the state variable, which is the environmental performance, and it's a bit similar to the other stream. This environmental performance can be improved by the abatement capacity investment, and then, however, it degrades when you have a larger demand. So this bracket term represents the demand, and you can see that it can be improved by the environmental performance. And this G refers to the unit pollution rate. So the G times D is the total emission, and this total emission degrades the environmental performance. So you can find a very interesting circular relationship, because on one hand, if you have increased environmental performance, it will increase your total demand, and this will have a fireback result, which decrease your environmental performance. So one of the main reasons that cause this circular relationship is that the G, the unit pollution rate, is independent of your investment in the abatement capacity. So in the next stream of literatures, it deals with the dynamic emission reduction with, in a way, the threshold in mind. So for instance, in this case, they have adopted the goodwill dynamics, and the goodwill can be improved by advertising, which is the capital AT, and can also be improved by the abatement capacity investment. And as usual, it suffers a natural decay. And they also introduce a state variable, which is called carbon reference. So basically, they will compare the current goodwill of the company with the reference effect, and then this will contribute to the dynamic evolution of the carbon reference. And both the goodwill and the carbon reference will subsequently affect the demand. However, if you look at the green accumulation, you will see that it's not very, you can hardly distinguish between the effect of the advertising and the investment in abatement capacity. So ultimately, the firm will just choose the one that is most cost effective. And most of the cases in real life, the advertising will be less costly. So very likely they will engage in greenwashing activities. And also it's very different. It's very hard to distinguish the goodwill and the carbon reference from the concept. So in the next two streams, they somehow capture the reference effect in a more, let's say, reasonable way or in a more interpretable way. So for instance, in this paper by Yao, the goodwill dynamics is again subject to the advertising. And then this term, the big bracket term, is when the consumers look at the total pollution, which is captured by the theta times the total demand, they benchmark with the industry standard, which is captured by the E bar. So if the total pollution is lower than the industry benchmark, the goodwill will increase. On the contrary, if they pollute more than the industry, the goodwill will decrease. However, with this extreme, first, it also suffers the effect of the greenwashing because advertising can also contribute to the goodwill dynamic. And the second, most importantly, is that here the industry standard is a constant over time. And this is somehow less reliable, credible if you are considering a game of infinite time horizon. There is also a huge stream of literature regarding the carbon cap and trade. I noticed that in 3 weeks, Zhang will present this paper, so I will leave the work, I will leave it to her without giving too many spoilers. But yeah, in general, the idea is that there is certain carbon emission cap, and then if you are emitting more than that, you are somehow penalized. So this will have a negative impact on your profit. But if you are emitting less than the carbon emission cap, you can trade it, you can sell this quota to other companies. So in a way, the environmental performance of the firms are also compared with a certain threshold, in this case, which is the carbon emission cap. And then the consumers will react to it, or it has a direct impact on the firm's profit. But similar to the previous study, the emission cap is also assumed to be a constant in an infinite time horizon setting. So our paper contributes to the literature by introducing the following elements. So first, we characterize the pollution explicitly. So instead of an abstract term. Second, we deliberately exclude advertising as a decision in order to exclude the greenwashing possibility. And thirdly, we introduce the benchmarking behaviors in consumer choice. So they don't blindly trust whatever the companies claim to be. They compare the information of the company with certain threshold and then decide whether they will buy the product or not. And lastly, when for the benchmark that the consumers use, this standard will not be a constant. However, it will evolve over time. So next, I will present how we incorporate all these elements in our model. So to start with, we have a state variable, which is the abatement capacity, which can be improved by the investment in abatement capacity and suffers a natural decay. So this is just in line with capital accumulation literature. And the pollution propensity of the manufacturer is characterized by a linear function and is decreased with the abatement capacity state. So to note that when at time zero, the manufacturer's pollution rate is characterized by the parameter theta zero, and then it will decrease when you have higher abatement capacity state. When it comes to the industry pollution level, is described by a time varying function. And at time zero, it can be characterized by these two parameters, epsilon plus delta. And then when the time approaches infinity, the industry pollution rate will approach epsilon. That somehow represents the lowest pollution rate possible that can be achieved with the scientific progress. And all the parameters are positive. When it comes to the green reputation dynamics, in the square brackets, you can see how is the benchmarking behaviors of the consumer. So at each instant of time, the consumers will look at the first element, which is the industry pollution rate, and compare against the manufacturer's pollution rate. So different from the paper of Yao et al., instead of comparing the total emissions, we are comparing the unitary pollution rate. So if the company is doing better than the industry standard, the green reputation will increase. Otherwise, it will decrease. And the demand will be enhanced by the green reputation. So this represents the fact that the consumers evaluate the sustainability and they take that into account when they are making purchase decisions. And also, the demand will decrease in the price, which is consistent with most of the pricing literature. So finally, these are the objective functions of the manufacturer and the retailer. So there is one parameter that I haven't introduced yet, which is the capital BT that represent the cost sharing rate. So in specific, this is the percentage of the abatement investment paid by the retailer. So this investment will be split between the retailer and the manufacturer, and this capital B will be a decision variable of the retailer. By the way, if you see the letters is highlighted in green, it presents the manufacturer's decision variable, whereas the red letters represent the retailer's decision variable. So the decision sequence are as follows. In the stage one, the retailer will propose a cost sharing rate, which is between 0 and 1. And then as follows, the manufacturer will decide how much he will invest in the abatement capacity, and then the wholesale price. And then finally, the retailer will decide the retail price accordingly. I forgot to mention, if we let capital B to be 0, it becomes a specific case where there is no cost sharing activities. So that represents the case when there's no vertical collaboration between the manufacturer and retailer, and it just reverts to a very typical wholesale price contract in the supply chain. So next, I will show the feedback document equilibrium in both modes of contracts, with or without cost sharing. So we will start by the cost sharing case. It looks a little bit horrible. So here are the 4 decision variables in the equilibrium. You will see that the first two represent the pricing decisions. First one is the retail price, and the second one is the wholesale price. And you can notice that they only depend on the goodwill state. The third one is the abatement capacity investment. It depends on both the capital K, which is the abatement capacity level, and the goodwill level, capital G. And the capital B is the retailer's cost sharing rate, and it also depends on the both states. We have Although we can express all the decisions in the closed form way, however, there were some coefficients that we can't characterize explicitly. So specifically, we have the M1 up to M6 and R1 up to R6. They are determined by a system of 12 differential equations. So they are all time dependent and we can't characterize the closed form. And also the manufacturers and the retailers' value functions are quadratic in both state variables. So if we look closely to all the decision variables, we can somehow characterize some information. However, we will defer a lot of analysis to the numerical simulation part. So let's first have a look at the pricing decisions. So both prices, retail and wholesale price, they increase in the green reputation, G. So that reflects the fact that the consumers are willing to pay a sustainability premium. And also the pricing decisions are independent on the investment in abatement capacity. But this is mainly due to the model setup, such that the K, which is the abatement capacity level, does not explicitly affect the demand function. Finally, if we characterize the equilibrium demand, you can see that the demand is increasing in the green reputation. So when you have a better green reputation of the manufacturer, your demand size enlarges and also the prices also increase. And this will ultimately translate to a higher profit for both the manufacturer and the retailer. When it comes to the investment decision and the cost sharing decision, it becomes less clear. But if you look at the system of differential equations that determine some of the coefficients, you can somehow separate them depending on whether they are dependent on the industry pollution parameters or not. So these three parameters describe how the industry threshold evolve over time. And all the parameters, all the coefficients highlighted in green, they are coupled and then they don't depend on the industry pollution parameters. So in a way, you can consider that when the manufacturer is deciding the abatement investment decision, he first will choose some baseline abatement investment characterized by the first two terms. And for this baseline decision, he will only look at his own abatement capacity level and the green reputation level. And then after choosing the baseline decision, he will look at the industry, which is characterized by the last term, and he will make some adjustment according to what is the instantaneous industry level. So such behavior is also somehow represented in the cost sharing rate chosen by the retailer. However, since it's expressed in a ratio, so the mechanism is somehow more difficult to characterize. So here in this slide, you can see the special case when we impose the cost sharing rate to be 0. So it corresponds to the equilibrium under a simple wholesale price contract. So you can see that for the first two prices, if you compare with the pricing decisions in the cost sharing rate, in the cost sharing contract, they have the same specification. Therefore, if you have the same goodwill level, then with or without the cost sharing, the pricing decisions will be the same. However, if you look at the abatement capacity investment, you will see that it's governed by different coefficients. However, if you look closely to the system of differential equations, you can also somehow decouple the effect of the industry threshold or not. So similar to the case of cost sharing, the manufacturer will also first make a baseline decision governed by the first two terms, independent of the industry threshold, and then make some adjustments accordingly. So as I mentioned before, since the solutions are quite complex and we can't really solve the coefficients in an analytic form, we have to rely on a lot of numerical simulations to get some insights. So here is summary of the parameters we have been considering. For the salvage function, we adopt a linear function depending on the final state of the abatement capacity level and the green reputation level. And we consider a time horizon of 15 and the discount rate to be 0.5. But we have also tested a longer or shorter time horizon. These are some demand parameter or cost parameter. And for the sensitivity analysis, we have tested different values for the green parameters. So the parameters highlighted in green, mainly related to the industry pollution propensity, so the industry threshold, manufacturer's pollution rate, the goodwill dynamics, and the abatement capacity dynamics. For simplicity, I have kept all the other parameters fixed. And one thing I would like to mention is that with this benchmark case setting, the initial industry threshold is 10, and then at the end of the planning horizon, the pollution rate becomes 8.4, and the lowest possible rate is 7. And I have set the initial manufacturer's pollution rate equal to the industry threshold, but we also test other different settings. So these are the set of parameters we have, the different values we have considered for the 7 or 8 sensitivity parameters we have considered. So the way we do it is we first use the benchmark values, and then when we were testing, for instance, this with respect to nu, we keep all the other parameters unchanged and simply change the values of nu. So we never change two parameters at the same time. So I will start by presenting the comparison of different equilibrium results. So with or without the cost sharing. So when it comes to the economic efficiency of the cost sharing contract, things are quite straightforward and intuitive. So basically across all the parameters we have tested, in every single case at any instant of time, the retail and wholesale prices are higher in the cost sharing scenario. The corresponding demand is also higher. And then in total, the manufacturer and the retailer's profits are higher. So note that in the profit claim, this higher profit doesn't happen in every single instant. However, but when you discount all the future payoffs to the current state, the manufacturer and retailer do receive higher profits in the cost sharing program. So these three results consistent with the literature of the advertising cost sharing program. So we can conclude that a cost sharing program leads to a Pareto-optimal outcome. However, when it comes to whether it's efficient in reducing the total emissions, things are more complicated, because if you look at the contribution of the cost sharing program, it has two effects. So first of all, since the cost sharing program enhanced the abatement capacity, and that results in a lower pollution rate. So as expressed in this formula, so under the cost sharing scenario, the unit pollution rate is lower. However, since the total demand is increased in the cost sharing program, we also attract some new customers they are either opted for a substitute in the case without cost sharing. I mean, in the case when the product is not so clean, or maybe they didn't even want to buy the product at all in the very beginning, but now since that, oh, this product becomes green, so they are willing to buy it now. I think the second effect can be best described by this marketing campaign by Patagonia. So in case you're not familiar with it, Patagonia is a very famous clean brand. So they insist on fair trade and then a lot of sustainability practices. And by the way, I'm not sponsored by Patagonia. And then during one Black Friday campaign, they released this advertising simply saying that don't buy this jacket. And this is a new product ruled out by the Patagonia. So their claim is that if you already have an old jacket and it's still working, it's still functioning, then don't buy a new jacket simply because it's a green product. It's an indie green product, but it will be more sustainable if you can keep on using the old product. So this is the second kind of negative effect of the cost sharing program. So ultimately, we are comparing these two effects to see which effect is more dominant. And so here we have tested different parameters, and then I have illustrated some results of the difference of the total emissions. So here the numbers, the big numbers in the boxes refer to the total emissions under cost sharing minus the total emissions under a simple wholesale price contract. Therefore, if it's a negative number, which is highlighted in red, it means that the cost sharing program has achieved lower total emissions during the planning horizon. So to start with, here I'm presenting the different results depending on the different initial levels of the abatement capacity level or the goodwill level. So you can see that the cost sharing scheme can lead to a lower total emissions over the planning horizon only when you have very high initial abatement capacity level or very high green reputation level. So the idea is that if the industry or if the product is already clean, then even with cost sharing, you make it cleaner, but the potential for market expansion is very limited. Therefore, you are somehow minimizing the increased demand effect, and then the decreased pollution rate effect will be more dominant. Therefore, in this case, you will achieve a reduction in the total emissions. So here I'm showing two different parameters, which is delta and mu. They are the natural decay parameters of the abatement capacity dynamics or the green reputation dynamics. So you can see that if they take very low values, highlighted by this 8 green and 8 red numbers, they can also, in a cost sharing program, it can also achieve a lower total emissions. So the idea is that if the abatement capacity or the green reputation is subject to a lower decay effect, somehow you can keep your green reputation higher without investing too much money. So in this way, the industry can quickly transit to a very clean industry. And then it will, as before, since the industry is already very clean, the potential for market expansion is limited, and therefore this effect is minimized, and the effect of the decreased pollution rate will dominate, and you will achieve lower total emission. When it comes to psi, just a recap, psi is the a parameter that represents the consumer environmental concern. So if a large number of sites represent that the consumer is very concerned of the environmental performance, and then they will update the green reputation quickly, and a very low value will indicate the country. So very interestingly, you can see that both low or high levels of sight, meaning either ignorant consumers or very sensitive consumers, can make the cost sharing program achieve lower emissions. However, it's through different mechanisms. When we have very low consumer environmental concern, it means that they don't care about the how the firms behave at all. So the goodwill gains from abatement are minimal, which results in a very limited market expansion. On the contrary, if the consumers place high value on how the firms behave, the firms are forced to maintain a very low pollution rate, meaning the low pollution rate will dominate the expanded market. So the next two parameters, theta 0 and theta 1, they characterize how the firm's abatement capacity, how the firm's instantaneous pollution rate is modeled by their current abatement capacity. So either low theta 0 or high theta 1, they both represent that the abatement capacity can more efficiently to a lower emission rate. Therefore, they emphasize the effect of the lower unitary pollution rate and make the cost-sharing program more effective in emission reduction. Finally, I will show how is the changing speed of the industry standard will affect the effectiveness of cost-sharing program. So interestingly, and maybe quite counterintuitively, when you have a low value of nu representing a slower decreasing speed of the industry threshold, you will see that the cost sharing will be even more effective in the total emission reduction. So this will be better understood combined with the sensitivity analysis that I will present later. But the general idea is that if the industry standard is decreasing too fast, it will be very difficult for the firms to keep up with the standard, or it will be very costly to keep up with the standard. So in a way, they will invest less and then rather to pollute more than the industry standard and suffer some goodwill loss. And that's why in this way, the total emission will be reduced. So next, I will move to the sensitivity analysis. So here is a summary of all the sensitivity analysis results we have found so far. So if you look by column, you will see that the effects are very consistent in most of the time. So for instance, if you look at the behavior of all the decision variables or the state variables with respect to the change of nu, you will see that a higher value of nu will decrease the value of abatement investment and also decrease the abatement capacity level. And accordingly, it decreases the green reputation level and decreases all the prices. And finally, it will decrease all the profits of both manufacturer, retailer, and the entire supply chain. So this kind of train rule, it can be applied to almost every single parameter except the parameter psi, which represent the consumer's sensitivity, environmental sensitivity. And one thing that is worth noting that if we look at the cost sharing rate of the retailer, for some parameters, we can't actually characterize how is changing, how is the direction of change, because it can first increase or decrease or the other way around. But later I will show a figure about this inconclusive effect. So we will start by one of the most interesting parameters, which is the industry threshold evolution. So here you can see that we have chosen 3 different values for the parameter nu. And if you set nu equals to 0, basically the industry threshold will be constant over time. So it will be consistent with most of the literature that consider a constant threshold. If you choose a value about 0.05, you have a almost linear decreasing industry threshold. And if you choose a higher value, you get a kind of convex decreasing industry threshold, which represent an industry where the standard can decrease very quickly. That might be due to some technological raise or some government scheme, government support, etc. So you can see that the manufacturer's investment, abatement investment will be the highest when the industry threshold doesn't change at all. And then it will decrease when the industry threshold decrease over time. So the main idea is that since the investment is dependent on the green reputation, and the fact that the industry threshold is decreasing over time makes the gap between the manufacturer's pollution rate and the industry threshold smaller, which makes the green reputation accumulation more difficult. And that contributes to a lower investment. I think this will be more pronounced when we look at this figure. So for instance, if you look at the solid line, the 2 lines that are highlighted, the blue line represents the industry threshold. As you can see in this case, is constant over time. And then the highlighted solid yellow line represents the manufacturer's pollution rate over time. You will see that it outperforms the industry all the way, so during the entire planning horizon, and the gap is quite big. But if you consider the kind of intermediate case, when the industry threshold is linearly decreasing, even though the manufacturers still outperform the industry threshold, but the gap is becoming very small. And in the last case, when the industry, the blue line on the bottom, the industry is convex decreasing, on the contrary, the manufacturer will be polluting always more than the industry threshold. So not surprisingly, this will cause the manufacturer's green reputation to be highest in the solid line case with constant industry threshold, and then in the middle when you have a linear decreasing threshold, and the lowest when you have a convex decreasing threshold. And since the goodwill expands the market potential, so when you look at the market, it has a similar shape of the goodwill dynamics. And ultimately, since both the prices will be dependent on the goodwill, the green reputation level, so they also show the similar shape as seen before. So one thing that is interesting to notice that if you look at the dashed line, so when the industry threshold decreases convexly, you will see that both the retail price and the wholesale price will approach the unitary production cost, which means that if the manufacturer is constantly polluting more than the industry, ultimately they will be excluded from the market. So dirty polluters cannot survive for long. Next, I will present some sensitivity analysis regarding the consumers' environmental sensitivities. So here is a recap of how the green reputation evolves. Here, the capital delta refer to the difference between industry pollution level and the manufacturer's pollution rate. So again, a higher side means that the consumers are very sensitive, and a lower one means that they don't care about the environmental performance. And from a different aspect, you can also consider whether the information of the environmental information is transparent or not. So in this slide, you can see a more intuitive case because when we are considering kind of relative medium to high level of the environmental sensitivity, you can see that first, if the environmental sensitivity is high, the company will be forced to invest a lot in the abatement capacity. And this will eventually translate to a much lower pollution rate, which is characterized by the yellow dashed on line in the bottom. So it outperforms the industry threshold all the time. And this will make the goodwill to be the highest among the three cases. So this is all very straightforward. However, if we consider the very low range, so if the consumer's environmental awareness is very low, for the investment and the pollution propensity is still quite straightforward. But if you look at the goodwill, you will see that when you have the solid line, which is the smallest environmental sensitivity and the most pollutant one, however, the goodwill of the manufacturer, the green reputation of the manufacturer is the highest among all three cases, which is very counterintuitive because you are polluting more in the solid line case. However, you get the highest goodwill. So the main idea is that if you consider the solid line, even though the difference between how much you pollute and the industry is big and is negatively big, since consumers place little attention on it, so the total effect, so this product size times the difference will be small. Therefore, it has a smaller negative impact on the goodwill dynamic. Therefore, in a way, the companies can escape from the it's kind of punishment free, even if they pollute a lot. So this will be translated ultimately to the profit. So if we plot the manufacturer's profit function or the total supply chain's profit with respect to the parameter side, you will see that it's not monotone. So it will first decreases because of this punishment-free effect, and then in the range with a medium or high environmental awareness, it will increase. So the second part is more intuitive. And also notice that if you keep on increasing the environmental sensitivity of the consumers, ultimately, both the manufacturer or the entire supply chain will benefit more from a higher environmental sensitivity compared with the low level. And finally, I want to introduce how the initial status would affect the company's behavior. So in the, as you can see from the left figure, in the beginning for the benchmark case, we have fixed the manufacturer's initial pollution rate to be the same as the industry pollution rate. And as a result, the company will always outperform the industry. However, if you increase even just by a little bit the pollution rate, in most of the time, the company will pollute more than the industry. And the same behavior can be found on the green reputation. Therefore, it says the inertia matters. So if you are already a very dirty company, so most of the time they will just give up. They wouldn't bother trying to catch up with the industry threshold. And lastly, this is just a figure illustrating how the retailers' cost sharing rate change with respect to one of the parameters. And as you can see, um, we can't really characterize how it's changing because depending on the value setting, it can be first increasing, decreasing, or the other way around. So we can't say much about how the cost sharing rate would behave. All right, so to sum up, so what we have found is that a cost sharing scheme is very efficient when it comes to the profit, in the sense that all the players, including the total supply chain, will achieve higher economic profits. However, it doesn't necessarily mean that it reduces the total emission across the entire planning horizon. It is environmentally beneficial in some of the cases. For instance, if the market is very clean or the consumer environmental sensitivity is either very low, they don't care about it, or very high, or when the investment efficiency is great or the industry standard decreases at a lower pace. And when it comes to the insights drawn from the sensitivity analysis, we can see that if the consumer exhibit very low environmental concern on emission information, um, which is characterized by the small value range of the site, the manufacturer can somehow avoid the consequence of not engaging in green innovation. Then as a result, if that's the case for the society, the government could try to enhance either information disclosure to make it mandatory or enhance the consumer awareness by education. So once they raise the size from the small range to the big range, and this positive effect regime will require the manufacturers to pay in a way for their pollution. And finally, if the company is significantly lags behind, so if they have an initial state which is far behind the industry standard, they will just give up. Therefore, the government can consider giving some boost so that raise them to be above or at least in the same threshold as the industry standard. And that would be all. Thank you very much for your attention.